I welcome you all to the session of engine system and performance, and in today's class we shall discuss about the measurement of torque, which is again an important quantity to be measured to predict engine performance. So, we have studied in our undergraduate internal combustion engine course. In fact, we have seen in the context of IC engine test that to measure the power output, typically we used a particular device, and that is known as dynamometer. So, today we shall discuss about this particular device, and we shall see using this device we can measure torque produced by the engine and thereby the output energy for the operating range of speed and load of the engine. So, dynamometer, if I write here, this is a device, mechanical device, which is used to measure torque and speed and thereby power output for the operating range of speed and load of an engine, right. And this dynamometer can be classified into two different categories. So, if I write here, this dynamometer can be categorized into two groups. One is basically known as transmission type dynamometer, and another category is absorption type. So, as I said that dynamometers are used to measure torque and speed of an engine over the operating ranges of speed and load. So, we can measure the torque. If we can measure torque, certainly we can measure the output power from the output power of the engine. Now, this transmission type, from the name itself you can understand that essentially we need to use a particular device to measure torque, and that should be transmission type. So, if I write here, in the transmission type, this utilize the device. So, a device is used to measure torque, right, in terms of elastic twist, or the device can be such that it can be inserted between two sections of the shaft and thereafter we can measure the torque, okay. Or special torque meter or a special torque meter is inserted between sections of a shaft to measure torque, okay, to measure torque. So, this is all about transmission type. What about absorption type? So, from the name again you can understand the output power which is produced by the engine, or the power that is produced by the engine or output power will be absorbed by some component of the dynamometer. Now, depending on the component, again this particular dynamometer can be classified into subcategories. So, if I write something over here, absorption type dynamometer uses methods. So, utilizes methods to absorb energy output of the engine. So, now this is what we can see, and since this particular dynamometer uses some means to absorb energy, essentially that energy will be converted into heat. So, that heat must be dissipated. Okay. So, this is the main classification of this particular device which is used to measure torque and speed, but you know that example of this absorption type dynamometer which we will discuss in this particular course are. So, if we go to the next slide, examples of absorption type dynamometer are mechanical, number 2 is eddy current dynamometer, C is electrical dynamometers, so all these. Typically, you know that in today's class we shall be discussing about this mechanical type, special mechanical type dynamometer, which is mechanical type dynamometers which are used to measure engine speed and torque over the operating ranges. Now, this particular mechanical type, again I should say that there are many. So, I can write here this mechanical dynamometer. One could be, so it can be further subclassified into two different categories. As such, two different mechanical dynamometers we will be discussing today. One is rough brake dynamometer, that is what is used in undergraduate internal combustion engine lab test or lab testing facility. Another is hydraulic dynamometer. So, this is these two we shall discuss in today's class. So, if we go to the next class, you know that again this absorption type that we have discussed so far, this absorption type rely on whether this absorption type can be further classified into further subcategories, and that is based on whether or not whether or not, if I go to the next slide. So, absorption type dynamometer. So, this particular type again can be further subclassified depending on the fact that whether or not they have the capability to motor the engine or spins the engine when engine is not producing any work output. So, let me tell you one thing, this particular type can be further subclassified into categories depending on the fact that, depending on the criterion whether or not this particular type of dynamometer is able to motor the engine or spin the engine when engine is not producing any output power. So, that way we can divide. So, whether or not this type is able to motor the engine, this is equivalently spin the engine, motor the engine or spin the engine when engine is not producing power. So, based on this hydraulic type is cannot motor the engine, this cannot motor the engine, okay, while electrical type they can motor the engine. Okay. So, now let us discuss about these two different types as I have mentioned here. One is rope brake dynamometer that already you have studied, and second one is hydraulic dynamometer. So, if you go to the next one, that is essentially the schematic depiction of rope brake type dynamometer. It is very easy to understand. What you can see from the schematic depiction is that in this particular dynamometer, so this is engine shaft. So, this is shaft of the engine, which is essentially rotating when engine is producing power, and a circular disc or drum is mounted on this shaft. So, this is essentially you can see this is a drum which is mounted on the shaft. So, as the shaft is rotating, drum also will rotate, and a few number of rope turns wound the drum. So, drum which is mounted on the engine shaft will rotate, and on the outside of the drum a few number of rope turns wound the drum, and the energy will be absorbed due to the friction of rope and the drum. Okay. So, as the and this rope, there are two ends of the rope, one end is having this or connected to the spring balance, another end of the rope is now having this load. Okay. So, when the shaft is rotating, drum will rotate. Now, if we try to give some load on one end of the rope, that will try to create some resistance or frictional resistance between rope and the drum, outside of the drum, outer periphery of the drum, and that frictional effect will absorb energy, and that is what it is absorption type. Now, depending on the load from the spring balance, we can really measure that is calibrated spring, we can measure what is the power output of the engine. So, this is the most simple one, but the limitation that this particular dynamometer, though it is very simple, but the accuracy of this particular dynamometer or flexibility is poor at higher energy levels. So, these are the simplest type of dynamometers, but not flexible as and accurate as well as other types of dynamometer at high energy levels. So, basically if we talk about electrical type or hydraulic type, they are flexible as well as they are more accurate. So, compared to these types, that is electrical type, eddy current type and hydraulic type, rope brake dynamometer is not flexible as well as accurate as well. So, this is the limitation. So, if I write here just for the sake of completeness, limitation is that this type is the simplest type, but is not as flexible and accurate as others at high energy levels. So, that means if we need to use this particular dynamometer for measuring high work output or high power output, this dynamometer may not be accurate as others. Okay. So, now let us go to discuss about this mechanical dynamometer, which is hydraulic type 1. So, as I said you that all these dynamometers are essentially absorption type. So, they absorb energy produced by the shaft, and that in absorption of energy will be an indication of the measurement of the power output of the engine. So, what we seen in the context of rope brake dynamometer is that that energy is absorbed by the friction between rope and the drum. So, that energy, as I said, whenever any component is absorbing energy. So, earlier case we have seen that is basically viscous, and so viscous friction. So, that frictional effect will give rise to heating. So, heat has to be dissipated, otherwise life of the components like rope and the material of the drum will reduce with time. So, in this particular type, from the name itself you can understand, though it is mechanical type, absorption type, but it is hydraulic type. So, essentially hydraulic, the word hydraulic is used to indicate that there is a working fluid, and the working fluid is water. So, like you have studied hydraulic machines. Hydraulic machines are those machines whose working fluid is water. Okay. So, here only hydraulic type. So, if we try to describe the constructional feature of this particular type, let me tell you. So, this is engine shaft and that is rotating continuously, and so if I write here, that will help you to understand first and then I will discuss. So, what you can see, this hydraulic dynamometer, whether it is type 1 and type 2, hydraulic dynamometers are used for measuring power of internal combustion engine or IC engine when power output and speed are very high. Okay. So, rope brake dynamometer cannot be used for this type of application. So, this is number 1, and we are discussing type 1. So, this type 1 and type 2, this is again based on the classification. So, hydraulic type can be classified into 2 categories, right. That is, number 1 is, or A is friction type, number B is agitator type. So, this is the first one that we are talking or discussing is friction type. Hydraulic type, but again hydraulic type can be classified into 2 different categories. Type 1, that is friction type. So, this is friction type. So, in this type what is happening, let me just so let me write or discuss the difference between friction type and agitator type. So, if you go to the next slide, then I will come back again to this slide. So, friction type So, you know this water hydraulic, the water is used as the working fluid, that water is used as the medium of momentum exchange, or you know that water is used to absorb energy. Certainly absorbing energy, water temperature will increase, but we need to have, or we need to control the amount of water as well as its temperature using you know servo electrical control system. So, friction type, in this type what is happening, you know that coupling force, what is this coupling force? So, if you try to recall the rope brake type, we had seen the force that is coupling. So, basically rope and the drum. So, outer periphery of the drum and the rope, so that there is a coupling force. So, here also, so one is you know stator, another one is rotor. So, rope is trying to retain or restrict the movement of the drum, and drum will be rotating because of the shaft which is rotating and which is integrated to the engine. So, the coupling force between stator and rotor, coupling force between the rotor and stator, between the rotor and stator, you know rotor and stator arises from the viscous shearing. From the viscous shearing of the fluid. While in agitator type, if I write here, agitator type, you know the coupling force so as if something is trying to you know coupling. So, the rotation should be you know restricted, rotation should be you know prevented. So, that part, if we need to prevent the rotation of the shaft, we need to have some forcing externally. So, that force will try to couple. So, that is called coupling force. So, the coupling force arises for this particular type, that is agitator type, arises from the change in momentum, from the change in momentum of the fluid, certainly water, I can write in bracket water because this is hydraulic type, as it is transported from the rotor vanes, from the to stator vanes and back again. So, this is what is the agitator type. So, based on this arrangement of momentum transfer rather, you know transfer of momentum from one component to another component, that is from rotor to the stator. Earlier case we used rope, but in this case the medium is water, that is fluid which is used to absorb momentum is water. In friction type only viscous shearing effect will be using, but here we will be using the change in momentum, but while we are talking about change in momentum, still viscous shearing effect will be there. So, here also we still have viscous shearing effect, that also will try to transport or transfer momentum from rotating component to the stator component. So, let us go back to the previous slide and let me discuss the operational or method by which the power can be measured, output power can be measured of the engine. So, as I said, you know that this is the engine shaft which will rotate, and this on the engine shaft you can see there are two stationary plates of the casing. So, this is the casing, and inside the casing we have water, right, that you can see from the schematic depiction. Now, this is rotating plate that you can see, that is also mounted on the shaft. So, and these rotating plates are mounted on the shaft, and as the shaft is rotating, this rotating plate also, rotating plate also will rotate. So, as the shaft is rotating, the plates which are the rotating plates, a rotating plate which is mounted on the shaft will rotate in tune with the engine shaft. Now, try to see, this rotating plate is now immersed in this water or fluid. Now, this casing is a stationary part which is connected to the shaft using tri-union bearing. So, this is basically anti-friction bearing, I should write. Anti-friction bearing. That means, as the shaft is rotating, normal tendency of this casing which is stationary will be to rotate in tune with the shaft as well. But try to understand, the water is now creating, or water is acting as a mediator, playing a role, rather water is playing a role or playing a mediator role. So, rotating this rotating plate, this plate will rotate in tune with engine shaft, which in turn will allow the stationary plate also to rotate, but and this momentum will be, so this is anti-friction bearing. So, there is no frictional effect. So, as the plate is rotating, that momentum will be transported from the rotating plate via this water to the stationary plate, and stationary plate also will try to rotate. Okay. If we can somehow prevent the rotation of the stationary plate, and if we place a load cell on the stationary plate, then from there we can measure what is the load. So, that is how we can really measure the output power. So, let me repeat once again, the plate is mounted on the engine shaft, shaft is rotating. So, this plate also will rotate, while rotating that energy will be dissipated to water. That water is playing a role as the mediator to transport or to transfer momentum from this rotating plate to this stationary plate. Since stationary plate is connected to the shaft through anti-friction bearing, the tendency of this stationary plate also will be to rotate as the momentum is getting transported from rotating plate to the stationary plate. We can prevent the rotation of stationary plate by having some braking action, that is called braking of the engine, and if we place some load cell, from there we can say what is the power output of the engine. So, this is how this mechanical type works. Okay. So, then if we go back to the next one, that is type 2, mechanical dynamometer hydraulic type 2. So, as I said, in this type that coupling force arises from the change in momentum of the fluid as it passes through rotor to stator and again back. So, let me discuss here a few lines, or let me I will write a few lines. Before writing a few lines, let me tell you the procedure by which this particular device is used to or can be used to measure power output. So, you can see, so what will happen, that you can see this is water in port through which water will come in. Now, when water is coming in, so this is the groove in the rotor. So, it will strike the rotor, and then from the water will take, or water direction will change. So, rotor will direct the water jet towards the stator, and again inside the, while it is striking the stator, it will again coming back to rotor, and that way toroidal vortex will form, that you can see from the schematic depiction. Now, this rotor is having grooved. So, water also will try to go to the another side, and again we have a stator. So, this part is stator, that is shown here using sky color. So, this is stator. and the stator is connected to the shaft using anti-friction bearing that we have discussed in the context of type 1. Okay. So, as the engine is rotating, rotor is mounted on the shaft, engine is rotating. So, engine is developing power, shaft is rotating, rotor is mounted on the shaft, it will rotate, but as the water is coming in, that water water jet will strike the rotor blade, rotor vane, again it will rotor vane will direct water to go to stator vane, from stator vane again it will come to rotor vane. So, momentum exchange will be there, and the tendency of that momentum which is striking the stator will be to rotate stator, but if we can somehow arrest the movement of the stator using a torque meter, and if we have a load cell, then using that load cell we can see exactly what is the amount needed to prevent the movement of the stator. From there we can measure the power output. So, let me write a few lines for this for the sake of completeness. Number 1 is water flows through the veins in toroidal vortex pattern. So, this is a special shape of the vortex that is being formed because of the shape of the rotor and stator vanes. So, number 2 is the water flow creates a torque. So, I am writing here. So, what you can see, the water jet is striking rotor vanes, and this rotor vane, this rotor direct water outward towards the stator vane. So, the water jet or water direct water strikes the rotor vanes, and then rotor vanes direct the water toward outward toward the stator vanes. Which stator vanes which redirect water back into the rotor. That is the process that I was discussing. Now, in the course of this phenomenon, if you go to the next slide, so we can see there will be a change in momentum. So, the change in momentum experienced by the water as it changes direction is manifested as a reaction force. As a reaction force on the stator housing, right. And so, as I told you, over and above this momentum change that will be experienced by the water as it changes direction is manifested as a reaction force on the stator housing. So, momentum will be transported, also momentum will be transported to some extent by the viscous shearing effect, okay. Because the tendency of the stator housing or stator would be to rotate as there is a change in momentum because that is manifested in as a reaction force. So, rotor will rotate, that momentum will be transported through the water jet onto the stator. Stator also will try to rotate, but the stator is placed on the shaft using anti-friction bearing. So, there will be no consumption of power. So, there is no friction, anti-friction bearing. Now, the normal tendency should be, normal tendency of the stator will be to rotate in tune with rotor, but here you can see the stator, the tendency of stator to rotate would be prevented by using some brake arm. So, that brake arm is having load cell. So, from there we can measure what is the torque produced by this engine shaft, and from there we can measure the work output. So, let me complete a few lines. So, for the dynamometer resists the torque, the dynamometer resist the torque reaction, that is reaction which is reaction force on the stator housing. Load cell of the dynamometer measured the so here I am writing load cell on the dynamometer measured the torque. Okay. So, the load cell signal needs to be amplified again to get accurate information of the torque that is developed, and as I said you that water temperature will increase in both the cases. So, also water will the amount of water will reduce with time. So, we need to replenish the water quantity, together with we need to maintain temperature of the water intact. So, some arrangement should be there, and that is done by electro-hydraulic servo system to maintain water temperature in a specified limit, and also to maintain the amount of water inside that stationary plate or casing for the first one, and also the amount of water should be used to absorb momentum from the rotor, and that would be transported to stator for type 2. So, we have discussed this. Now, let me tell you one important thing, that in this particular case, if we talk about the hydraulic type, hydraulic type, whether it is type 1 or type 2, the absorption capacity or horsepower, absorption capacity, that is absorption of energy, or horsepower is approximately function of cube of the rotor speed, and therefore, it is suitable for testing high speed engine. So, this is the conclusion, and if we tell a few words about this, if we go to the previous slide. So, this is that as compared to mechanical type, it is economical, and also since this particular type can be used for testing high speed engines. So, this hydraulic type has or is used widely for the measurement of engine power through the measurement of torque and speed. So, let us now solve one numerical problem to illustrate that concept that we have learned today. So, if we go here, so this is the problem statement. Let me read the problem statement first, then we will solve. So, you know that the problem here is to calculate the brake power. Essentially, we need to brake the engine. So, engine will be running, shaft will be running or shaft will be rotating. So, the energy that will be produced by the engine should be, we need to brake the engine. So, we need to brake the power rather. So, we need to absorb the power. We need to so far we have discussed about 3 different types, that is rope brake, hydraulic type 1 and type 2. Our objective is to prevent the motion of the stator in the 2 letter cases or letter 2 cases, while in the former case we had tried to restrict the motion of the drum itself. So, essentially we are trying to brake the power, and that is why we need to know the brake power. So, if we solve this problem, as I said that the statement is the speed of an engine is 450 rpm, load on the hydraulic dynamometer is calculated as 790 Newton, the dynamometer constant is 11,200, calculate brake power of the engine. So, that is the brake power, that is the power available at the shaft, and that power should be measured using, that power is measured using this hydraulic dynamometer. So, nothing is mentioned about whether type 1 and type 2, whether type 1 or type 2 is used, but let us solve this problem. Solution. So, you know that this, while calculating brake horsepower, using the method that we have discussed today, we have discussed 3 different dynamometers. This BHP is calculated using this formula, that is W into N divided by K. Let me write here what is K. K is dynamometer constant. So, this is typically provided by the manufacturer of the dynamometer. So, I am writing here manufacturer, W is load on the dynamometer. And N is certainly speed. So, what we can see from the statement that speed of the engine is given 450 rpm, load on the hydraulic dynamometer is calculated at 790 Newton, that I told that that in the stator itself load cells will be there, and load cells essentially that you need to have some brake arm to prevent or to stop the motion of the stator, which will have a tendency to rotate in tune with the rotor motion. So, from the load cell, if the signal will be there, sometimes or many times we need to amplify the signal depending on the requirement. If the power produced by the engine is very small, and then perhaps we need to amplify the signal to get the accurate data. So, now from there we can calculate the load on the dynamometer, and that is 790 Newton, that is given in this problem. The dynamometer constant is 1100-200, that is the value of K. As I said, this is provided by the manufacturer. So, straight away we can calculate the BHP. So, if we calculate BHP here, so BHP brake horsepower using this formula is 790 into 450 divided by 11,200. So, that is the brake horsepower. So, it is very simple and very straightforward. So, essentially what you can see that that this brake horsepower can be calculated quite easily using the dynamometer, as the dynamometer constant is provided by the manufacturer, what we need to know is we need to know the engine speed, that we will know using a tachometer that we have discussed in one of the previous classes, and this load on the dynamometer can be measured using load cell data. So, we have with this particular problem we had seen that using dynamometer the brake horsepower can be calculated. So, if we try to summarize our today's discussion, we have talked about a special device dynamometer which is used and for measuring engine power or engine output power, an important quantity. Essentially, by knowing the engine output power we can certify or we can predict the engine performance. So, and then we have solved one numerical problem, though it is very easy, just to illustrate that the conceptual part, that is or rather the methodical part that we have discussed today, and then this particular problem will help you to understand by how we can really calculate the brake horsepower. So, if we discuss now what we had solved, what we have discussed in a few previous classes in the context of engine performance, we have discussed about the measurement of a few important quantities like speed, then air flow rate, then fuel flow rate, then indicated work, and today we have discussed about brake horsepower. So, indicated power, that is the power available inside the cylinder, certainly that power is not available at the engine shaft. So, today we have discussed about brake horsepower measurement, which is the power that is really obtained from engine. So, these important quantities, the measurement of these important quantities have been discussed in a few lectures. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.